Good morning, students. In today's lecture, we will talk about basic glassware and equipment safety. Since each lab using different glasswares as well as there are different equipments and their safety is very important while using or like working on different equipments and as well as on working with different glasswares. So we will thoroughly talk about these two small contents, glassware is, as well as equipment safety. Since most of the experiments we have to use glassware, so special caution or attention should be given to the glassware handling. And this is very common observation in many laboratories. Uh, the accidents involve like cut or the puncture of wounds is very normal or like routine work. But of course, it depends on the worker or like the students or those are working in that particular labs. So while you are working on glasswares, so never try to push or like put a force on any glassware while inserting or constructing any experimental apparatus into the particular like working sites. And similarly, there are certain petri plates and there are a lot of other utensils or like the glassware that is being used, and of course several time might be you need to wash or might be you have to insert like different solutions as well as add a magnetic the elements while you are preparing some solutions. So those are the common the observations like the while the like non-professional handling can cause like this kind of glassware hazards. So always prefer to use proper like hand protections when you are going to handle or when you are going to use certain glasswares. So it depends like in different situations you have to handle glasswares. For example, sometimes it's hot if you are going autoclave, or sometimes it's very cold while you are using some freezers, and sometimes of course it's normal but you have to insert into the particular like apparatus into the labs. So this is really very important to handle the glasswares very carefully, because if there is a the breakage of a glassware, it will definitely directly involve to make like a certain damage to the body of the worker. So in this slide you can see an explanation of how to handle glassware. For example, here you can see this is a thermometer and we are going to insert like with the plastic holder, and this is very important. If you are pushing this thermometer into this plastic holder, so if it's not properly lubricated and also if it's look like hard while pushing and you are putting like the glassware inside these rubber bands, but of course you have to wear gloves as well as we need to lubricate this the plastic holder, and then of course carefully like insert this thermometer. If you push like with hard like the putting the force, then might be it can a danger to your body parts like your hand, and it will break down. Okay, so it can cut your body. So this is just one example, and several other time you have to work like on glasswares like these kind of insertion as well as removal of particular glasswares from certain experimental procedures or apparatus. Here are a couple of more examples. You can see like we have to handle like glasswares into particular apparatus, like you can see like here how like these metallic rods are fixed or like they hold these particular glasswares. So while you are fixing this one, so this is really important to remember always like how to handle glasswares. And similarly, when you are going to use different shakers, of course you have to fix your glass bottles into this shaker. So of course handling is very important. And of course if you are going to weighing some flask with the solutions or with the chemicals, of course these operators you definitely use. And after washing, of course all glasswares are handled are like for the removal of extra water, and you can just display on the bin. So you can see like this is also very important and delicate. The care is very really very important. And if you are going to weighing something, and of course you need a special apparatus while you holding like the glassware. So all these information showing like how this the sensitive to work with the glassware, and the handling and proper PP is very important, right? Rather than just a conventional way you are dealing with the glassware. To avoid like any injury, definitely you have to take care of all these cautions. In most of the laboratories, there are normal equipments that are used in almost like in level 1 or level 2 labs, BSL 1, BSL 2. But however, some labs are have some specialized equipments. But these equipments you can see almost like I'll have like fume hoods, laminar flow, hot plates, mixture, centrifuge, autoclaves, and some labs, of course, according to the uh, the level of the lab. Some labs have biosafety cabinets, so we will all cover like about these equipments and their safety into these lectures. So let's talk about the electrical equipment, because we did not talk much about glasswares, because in general, whenever you are working on the glassware, so you should like handle the glassware carefully. But this is really more important to talk about like certain equipments, because you have to use like individual equipments. Okay, so you need like information about the individual equipment and their nature of work, so that you can safely can work on these equipments. So there are some many of course electrical equipments, those are used in the labs. So this is very important to first, while you are using any equipment, so see this pat, this sticker. So this is a portable appliance tester. So like kind of if this sticker is available, so it will tell you like whether this equipment is working condition or not in working condition. Of course, most or majority of the equipments are working. There's no any equipment like in our labs like that is not working. But even then, this is a the rule, or like you make your the protocols like that. First of all, you have to check this sticker. Never use defective equipment. So of course, if sometime might be like this pat sticker is okay, but sometime maybe like a few days before, like there is a damage of the equipment. Okay, so if it's not like the lid is working, for in this case you can see this is a PCR machine. If the lid is not working, and in this case if you see here, this is a small or like a mini spin, and if the lid is not closing properly, then it can damage to the worker, because this it can run like I think 12,000 rpm. And similarly, this is a kind of incubator or like autoclave, small one. And of course, if it's not working properly, so don't use this. Since I'm from College of Agriculture camps, so I will particularly talk about the labs in the camps, because I know like much or like the more about our labs instead of like College of Medicine or the health sciences. Of course, they have some extra things, because they are working like on the blood samples or the human specimens, and they are more sensitive labs. But of course, I have knowledge about like those labs as well. But in particularly the equipments that we have like at camps, we will talk about. And we regroup, or like we group these heavy equipments into three groups. So those are like chemical fume hoods, biosafety cabinets, as well as laminar flows, benches, and tissue culture laboratories, the cabinets. So we just group them like into three particular groups. Let's talk about the chemical fume hoods. Chemical fume hoods are installed to protect the experimenter from the airborne substances like gases, vapors, mist, or fumes. Those are generated by the experiments. So while working in hood, not like put your head inside, because here you have like a sitting stool, and of course you are working here, but not like insert your head inside. Only insert your hands inside, so that you can avoid like maximum contaminations. So this is very simple, the chemical fume hood. So we will go for the next. These are laminar cabinet floors, or the laminar flow cabinets. So they provide actually sterile working conditions or the environment in order to protect specialized work, your experiments, to avoid like the contamination. So they create a particular free working in my environment, because due to this different construction of these cabinets, because they have like specialized filters and different like the air passage. So you can see like it has different apartments, you can see here, and here are like the different air passages where it can uh, provide like a full environment protection to the experiment. So they also provide excellent clean air environment, because not like contamination can go from outside to inside. Okay, so because the here are there is a the different the body parts, and they have equipped with the specialized filters as well. Okay, so in this way, so there is no chances of contamination of your experiment. Laminar flow cabinets are subdivided into two groups depending or like on the flow of their air. For example, the horizontal laminar flow, and the second one is the vertical laminar flow cabinets. So in horizontal laminar flow, air flow actually so you can see here, this is the working area. Okay, so the air come from up and then start and then pass like horizontally, and then it goes like outside in the horizontal direction. But in case of vertical laminar flow, the air flow like vertically, and of course it goes into these. Here are actually the area and backside and then the front side. If you see like practically and visit the lab, so you can see there are different holes, so where air can pass on. And in this way, like in the vertical laminar flow, so they provide like better protection compared to the horizontal laminar flow, because they come like from upper side and go downside directly, and in this way no contamination can come that can harm your experiment, and also like it protection your research. Laminar flow benches work better for the experiment, but it will not protect the worker. For example, because due to the airflow from in laminar flow benches, the airflow from inside to outside, not like from outside to inside. So in this way, to protect the experiment better, because here you can see here is a, for example, your experiment and air blow like this. Okay, so it will protect the experiment, but of course it will not protect the worker, because here is, for example, the worker is here sitting, so it will, the air is coming towards the worker, so it is better provide like protection to the experiment, but of course not like the better protection to the worker. In biosafety hoods, most of the air is recirculated, so and form a barrier across the opening of the sachet. So there are different like the sachet openings here. So in this way it will provide like potentially like the microorganisms protection to the worker. And also, since they contain very specialized filters inside this biosafety hoods, and also they provide like the clean environment, because the air is filtered inside these hoods. So I will, I think, show you a couple of more examples of these filters in coming slides. Biosafety cabinets are actually the best the cabinets, those are can be used for the sensitive experiments, because they are enclosed, you can see. So they are enclosed and they ventilated places. They provide like ventilated places to the workplace areas as well as to the experiment. And also they are very helpful, or very friendly with the environment from the micropathogens, since they contain kind of HEPA filtered. So these filters are very strong, and they remove all like hazardous agents, microorganisms, micropathogens. Okay, so these are equipped with these HEPA filters, and once the air pass through them, and the air become like a clean, and it will also protect you, not only protect the experiment but also the worker. Okay, so because the air the circulate within these filters, and it become a clean. Biosafety cabinets are divided into into three classes: class 1, class 2, and class 3. Class 1 actually provide protection to the user and the environment, like the surrounding environment, but it will not provide protection for the samples. Those are being like manipulated due to the direction of the airs. So the class 2 provides protection to the user, like user mean like worker, environment, and the sample as well as. So it is divided into further four types, like A1, A2, B1, B2, B2. Okay, but we will not talk like thoroughly about these subdivisions of this class second biosafety cabinets. Just you just remember like there are certain subdivision or subtypes of class second biosafety cabinets. Then class third or class three, they are also have glove boxes. They are also known as glove boxes, provide maximum protection for the laboratory worker and the sample of interest. So depending on their construction and as well as the installation of different filters, so these classes are divided and according to the protection they are provided to the experiment or like as well as to the in this slide you can see the comparison of all these fume hoods about the fume hoods, laminar flow and biosafety cabinets. So here you can see like how they look like. They are like look like these. So this is the biosafety cabinets, laminar flow and the fume hoods. But here in this side, if you see here, for instance, this is the worker and this is the fume hood, and you can see like the air flow is from here. So the air enter from this because this is the glass door. So this is a glass door in each cabinet. So whether this is biosafety cabinets, laminar flow. So this glass door is a sliding. So you can adjust. The height of this glass door according to or the height of the worker. So the most important thing is to see the airflow. So air enter from here and then the exit is on this side. So you can see like air directly go here and while moving inside and then go or exit through this side. And in case of laminar flow, so you can see like the air is coming outside. So air enter from here. So these are the filters and you can say here's a sample and then there is a this is the top of the the bottom you can say like the of the bench and the airflow come towards this side. So it means it will not protect if this air going outside, so this air not protect to the worker. And if you see the biosafety cabinets, the flow of air from outside from external environment to the internal environment, but here you can see how the flow goes on. So here is the the passage, so where like the air enters and then go here and then it enter into the filters here. Okay, you can see here there are the filter. So the filter clean the air and then it comes onto the experiment. And then of course even here is also the filter. So two times like air is passed through the filters and these are the HEPA filters. In this way it will clean the air, that is not only protect your experiment but also protect to the worker. But in other cases in laminar flow you can see this is not like protection provide any protection, and similarly here so the protection is not like the good. Even for example there are chances, but of course here are maximum chances like the contamination can come outside. But here you can see like there are two specialized filters are used and the first air is filtered and then of course is being used. So this is very nice like biosafety cabinets well secured like while working on these biopathogens or like hazardous biochemicals or the the materials. In this slide you can see the structure of the HEPA filter. So they are very nice you can see like the continuous sheets of this filter, and it look like very nice and very impact and infusion, and you can see like once air pass through this one and how they make the clean air. So here are general working considerations whether on biosafety cabinets or any laminar hood or like a fume hood. So these are the the general consideration or the instructions for all these cabinets. So first is for example while you are working on any cabinets, so the single person will work, not like two persons work. This is not good idea. Of course under certain situation, if for example someone wants to demonstrate you or help you, so the other person can for a time being can assist you while assist you for a shorter period of time. Okay, and secondly the height. So the height of your body chair, everything is very important because this is the bottom of this working the bench. Okay, like this cabinets. So your height is much more important, so that your elbow should be like on the bottom, or the on the base of these cabinets. Okay, so this height is very important, because you have to face in under certain situation like the airflow as well as the experiment protection. Okay, and never enter your head inside inside these cabinets. Okay, so at the moment you see like this is the surface, is actually the head is outside. Only insert your hands inside. Okay, so your maximum body parts will remain outside of the cabinets while working on these any cabinet. So this is really important to understand while you are working on the hood. So because ensure that it is really indeed like working, because the air pulled from the room into the hood. So this is this flow of air we need to first check, so whether this is a functional or like taking air or not. And secondly, while working on these hoods, especially like chemical fume hoods, so light piece of material used so inside, because of course not like take a heavy material, so you can use like light tissue papers or paper rolls, or not like take like too much material inside. And secondly, like not store like too much material, so the things or the material or the any flask or any tubes, whatever you needed for particular experiments, take inside, and after you finish the experiment, then take out. Don't like store or like keep your material inside that fume hood. Secondly, also work on slightly alleviated surfaces. So since we need to also remember the flow of the air. Okay, so slightly, just from the bottom. So as I mentioned, so if you just work like slightly up, then it's easily air can flow or can move, and then you can secure your experiment as well as provide like maximum protection to the experiment and by yourself. Moreover, when you are working on chemical fume hood, so keep the hood low as low at low level, so that you can save your energy, as well as air is pumped out of the the building is very easily. In any case, of course, never put your head inside, as I mentioned earlier. And good housekeeping practice is very important, like cleaning inside, so to avoid the contamination, because these are the particular the workplaces where many people like work like one and after. So if everybody like take care of your like good housekeeping, then of course there's no like a dirty environment inside the hood, and everybody can work like freely, and they can also protect their experiments. And if you, of course, if you found any the malfunctioning of the hood, so then of course don't work on that hood, and just report that incidents, or like report to the technician or the supervisor. So while working on the biosafety fume hoods, this is really important to understand according to the nature of the cabinets. For example, in biosafety cabinet, air is drawn from the front of the cabinet through the slotted area, and then of course it will goes to the top where the air is filtered and returned back to the front of the cabinet. Okay, so then of course. This direction of air is very important, so that you cannot block that particular area, the slotted area where you are sitting. And also 10 to 30% of air is exhausted in every cycle. So it means if this percentage is exhausted within 10 the every cycle, so the same amount of definitely air is drawn from the room. Okay, so this is really important. Then don't block that particular area, so that the same amount of air can be drawn is possible. If you block that slotted area by putting your elbow or some hands or some maybe like your tubes or like a flask or any petri dishes, and if you make like that blockage, then of course it will not draw the exact amount of air, and of course it will be the working will be not like normal. Okay, so it will cause your experiment malfunctioning or maybe contaminations. In biosafety fume hoods, of course, so this good housekeeping is always essential for every experiment, especially these cabinets, because they are common places. This is not like your particular working space like as you have in the lab. So always use clean or dry like the fume hood, and once you finish, and of course always clean it, and then leave it. Okay, so apply decontaminations, of course, usually like a 70% ethanol or formaldehyde, whatever the chemical is available. So off and on use to decontaminate the surface of the cabinets. Okay, so this is off and on, and of course, like all this protection should be done. So while working with laminar flow benches, because in the previous slides I mentioned about the flow of air into different cabinets. So in this case, of course, the air is coming outside, so you can see like it will provide a gentle filter air onto the worker. So because it will not provide like the good protection to the worker. And of course, never be used with pathogen. So never use any pathogenic or toxic environment materials. So because the air pass towards the worker, so it can hurt or can be dangerous to the worker. So normally, like these laminar flows are used for particular purposes. For example, tissue cultures are to make certain medias, sterile medias, and if you need to prepare some solutions, those are not like very dangerous, and but they need somehow some protection. So you use for those purposes, but not like very sensitive, like the experiments like the biopathogens. Those are have some toxic effect or the hazards. So otherwise, they will also not provide protection to the workers. So since the airflow is towards the worker or the benches, and in this way the contaminated air can also cause the hazard to the worker or infections or whatever. There are several research equipments instead of these cabinets, and those individual equipments can be used in the research. And of course, due to the presence of electricity and some conductive fluids or high pressure or high temperature, or some are equipped with sharp blades, so there of course protection is very important, and to understand about like their hazard is very important. And the best option is, while you are using any equipment, first get information from the manual, or like if there is a MSDS document, or like you can get like the basic information about the usage. And then of course you need to understand or remember the basic rules. Those can be helpful to avoid any risk of hazardous conditions. It's really very important to use like a simple electrical connections, and avoid like multiple extensions or plug converters insist of equipment. Because some equipments are actually might be not like connected, and you need like to put like extra connection. So at that time you should be like very careful about like the voltage, as well as like the extension wires, the capacity, as well as the the sockets, what if the other equipments are also connected into that particular sockets. So all these electric outlets in the laboratory are connected with the ground wire and protected by different fuses, differential fuses. So of course, so this is kind of the basic, the rules that you need to follow, like while using any individual equipments. Those are not like actually the stable condition, but you have to make a connection. Let's talk about the centrifuges, very commonly used equipments. There are different types of these centrifuges. There are mini centrifuges, there are medium, and there are some high, like the efficiency centrifuges. Those are also equipped or controlled temperatures, and some are like a kind of they just work like without temperature, but only provide like a centrifugation process. So there are so many, and according to their size is different, and they also have equipped like different rotors, and their rotors, depending on their rotors, so they are also can take like a different tubes. So the tubes and rotors, so they are actually interconnected. Okay, so the rotor define like which type of tubes they can take into that particular centrifuges. Of course, since they as I mentioned, their speed is very high, so this is really important while you are using. So let's say if you are going to start, and if you feel unusual like vibration, because for example 1000 rpm, 13,000 rpm, or like 15,000 rpm, you are going to centrifuge, or you are going to spin your solutions or any chemical or like any extracted material. And once you start, if you feel like there is a unusual vibration, so then it means there is a problem. So sometimes there is a the chemicals are not in the balance condition, or sometimes like uneven balance or uneven composition, or like the number of samples they can produce like this unusual vibration. So then at that moment just stop the machine and double check. Okay, so never run the centrifuge under unbalanced condition. This is really important, otherwise it will hurt to the worker. So never introduce a hand in or finger or anything else into this while using centrifuges. And particularly when once we are going to stop these centrifuges, and sometimes it takes little time, and it has automatically the braking system, so you don't need to insert your hand or finger to stop it, like to save your time. Okay, so it will automatically stop because it has a natural the equipped with the the automatic braking system. So once the brakes take place in the center, you stop the machine. So clean and dry rotors and surrounding chambers. So sometime might be your tubes. So you insert the tubes and it has like a certain kind of chemicals. And sometime if the lid or the cap is not well capped, tightly capped, right? So sometime might be liquid can go inside, and also can the it can spill outside. So of course, while after using, you just clean it very carefully. Let's talk about autoclaves. These are also commonly used equipments in the lab to autoclave all kind of contaminations. And so to avoid any contamination, so you have to prepare some solutions, etc., and then make an autoclave. So they work like the pressure cookers, because high temperature, high steam inside this equipment, and automatically they do like a very nice the autoclave products. So but make sure like some not autoclave solvents or oxidizing agents. Okay, because since these autoclaves work at high temperature and high pressure. Okay, so these solvents are oxidizing chemicals agents, so they can become like explosive if you are going to uh, autoclave those chemicals. Always check like while you are going to autoclave any chemical, whether their instruction mention like it's showing that you can autoclave or not. So even if you're using like the normal autoclave, like okay. So of course each autoclave has particular like operating procedures. In most of the labs they already mention the operating procedures, and also it includes the images, and that show like a loading and uploading of the accessories inside the autoclave. And then of course you just follow the steps, and then there are certain water levels. Of course you need to check everything like what is mentioned in the operation manual. In operation manual should also possible error message sometime. Of course if there is some error, so you can also double check, double confirm with the operation manual. Sometimes it says like water level is very low, or like a fuse is broken, a door is not locked. Okay, so follow those instructions, and then of course you can fix this is very easily. So where the appropriate safety. So as I mentioned, autoclaves like work for high temperature and high pressure. So of course proper PP is very important. Okay, so not wear like the normal gloves. Okay, so because they at high temperature might be like the normal the vinyl, or like the gloves, so they can melt, or they can cause burn on your bodies. So after sterilization, of course all the medias, waters, everything whatever you did, it's very hot, so be careful while handling those stuff. And also better to use like to protect your face also, because sometimes while you are taking out stuff, so might be like due to high pressure, some liquids can blurt out. Okay, so it can splash and can not be okay, so better to protect your face also. After autoclaving, the once autoclave is finished, so usually it take like I think 1 hour, 1.5 hours. but of course due to high temperature it will take some time to so that the temperature is going down. So but once you open the autoclave, and of course there is a lot of steam inside, okay, it will come outside. So be careful like while you opening the chamber of the autoclave. Okay, so and of course let the glassware cool down before you uploading. Okay, don't be like hurry while you are while once it's finished and just so I should suggest you just whenever you are going to autoclave any material, whether it's a flask or liquid media whatever, so give enough time. Okay, not like once finish and then you just start proceeding. Give enough time, 2-3 hours, and once it's finished it will stay under slowly temperature and steam will be down, and then you can of course you can unload or you can take your stuff outside from the autoclave. Since due to the high temperature most of the liquids are expanded, and of course while you are preparing your stuff for autoclaving, so keep like you know the air space at the top of the container. So it means like if you are using like container like flask 500 milligram flask, and just make like 300 milligram your stuff like the solution or the media or the water level. So keep like 200 like space, okay, so that once is the liquid expands so it will not explode to outside. Okay, always don't like fill the whole container while autoclaving any chemicals. So this is very important. So uploading the autoclave objects at one of the tray place nearby. Of course, this is kind of all like a general handling. How you will handle like a highly hot and you know the steam chemicals. You know after finishing the autoclave. So this is just to go through this. You know the instructions and then of course follow these instructions. Then fridges and freezer, they very commonly use equipments for to keep like the DNA, any specimen at a certain temperatures, because we have like a full range of fridges and freezers, for example, from 4 degrees Celsius to the minus 80 degrees Celsius. So freezers, so we have like minus 80, minus 70, and minus 70, minus 80, like the 3 times of high like you know frozen freezers. And of course we have other range like 4 degree, 18 degree, and minus 25 degrees Celsius. So all these different kind of temperatures provide protection to the specimens while we are going to frozen into those fridges or freezers. So depending on the specimen and the timings. So if you are going to store your specimen for shorter time, so of course you will use 4 degrees Celsius, and if you are going to little longer than 18 or 25, and then if you are going to stock like for years or for longer than years, so then you can go for minus 80, minus 70 degrees Celsius. So there are like two main safety issues with these fridges or freezers. So the first one is the cross contamination, and the second one is a freezer can burn your skin due to high temperature, as you have like in other ways like minus degrees Celsius. Okay, so due to the low temperature, very high low temperature, you can say it can cause also the burn. For example, if you are taking your specimen from those are already frozen inside the inside freezer, so it can burn your skin. So be careful, use like a proper PPE. And secondly, because these equipments are for all students or maybe like for all other employees together, they can put, because they are very limited number. So there are chances of cross contamination. For example, one example can contaminate with the other. So the arrangement or organization is very important while freezing any of your specimens. Here you can see to how we can avoid those contaminations. So there is some possibility in some freezer, especially like on the small freezers like minus 20 or minus you know the minus 20, minus 18 or 4 degrees. So there are certain cabinets, so you can select or separate or like divide the specimens according to the nature of the specimen into these cabinets. And never allow food or drinks, of course. These are fridges and freezers, of course, not what you are like eating or drinking you know the stuff inside these fridges or freezer. To avoid freeze burn, it's better to use like insulating gloves or like mittens. So these provide like best protection while you're dealing with the specimen. Those are taking out from -20, -80 degrees Celsius frozen temperatures. So I think this is all about like the common equipments those are using in the lab and glassware. So I hope like there is no like a difficult question. So if you have any questions, so we can discuss later. So thank you so much.